As our application grows in complexity, we need to make sure we're writing code that is not only functional, but also maintainable and reliable. This is where linting and type checking come into play. While Python's dynamic nature is one of its greatest strengths, it can also lead to subtle bugs that might only surface at runtime. For a production application, especially one handling asynchronous operations, we want to catch as many potential issues as possible before our code even runs. Think of linting as having a very experienced Python developer looking over your shoulder as you code, pointing out potential mistakes, style issues, and areas that could be improved. The linter helps maintain consistency across your code base and catches common programming errors before they become problems. This is particularly important when working in a team, but even for solo developers, it helps maintain high code quality standards. One of the most powerful tools in our arsenal is mypy, a static type checker for Python. While Python is a dynamically typed language, it has supported type hints since Python 3.5, and these have become increasingly sophisticated with each new Python release. Type hints serve two main purposes. They make your code more self-documenting, and they allow tools like mypy to catch type-related errors before runtime. Let's look at how type hints work in practice. In our counter application, we've been using them in our function signatures. For example, when we defined our database connection function, the past database annotation tells both our IDE and mypy that this function will return a database object. If we accidentally tried to return something else, mypy would warn us before we even ran the code. Type hints become even more valuable with async code. Consider our counter route. The str return type annotation makes it clear that this route will always return a string, even though it's doing asynchronous database operations. This helps catch errors where we might accidentally return something else, like a database result object. By combining linting and type checking, we create a powerful development environment that helps us write more reliable code. Let's set up these tools in Visual Studio Code, which has become the de facto standard for Python development thanks to its excellent debugging capabilities, extensive marketplace of extensions, and fantastic container integration. If you are not using VSCode, you can skip the rest of this module. There are two approaches we can take to set up our development environment. We can work directly from our host machine with a local Poetry installation, or we can use VSCode's devcontainer feature. Let's explore both approaches so you can choose what works best for you. Let's first set up our local environment. We'll start by creating a VSCode configuration that will allow us to run and debug our application. First, create a .vscode folder in your project root, and let's add a launch.json file. This configuration tells VSCode how to run our Quart application in debug mode. We're specifying our manage.py file as the entry point and enabling debug mode through the Quart debug environment variable. We'll also need a settings.json file to configure our Python environment and testing setup. These settings enable PyTest as our test runner and configure automatic code formatting when we save our files. Remember that for this setup to work, you'll need to have the Docker database container running since our application depends on it. To set up the local environment, make sure you're on the backend service folder and run these commands in your terminal. Make sure you have Python 3.10 available locally. If you don't, I recommend you install the pyenv package and follow the instructions. This creates a new virtual environment using Python 3.10 and installs all our dependencies. Before we can start coding, we need to install some essential VSCode extensions. Open the Extensions panel and install the following. The Python extension is the foundation of Python development in VSCode. It provides IntelliSense, debugging capabilities, and integration with various Python tools. It's the main extension that powers our Python development experience. The Black Formatter extension enforces a consistent code style across your project. Black is nicknamed the uncompromising code formatter because it has very few configuration options. It formats your code in the one way it thinks is best. This might seem restrictive, but it eliminates endless debates about code formatting in team settings. The iSort extension automatically organizes and formats your Python imports. It sorts them into sections, standard library, third-party, and local, alphabetically within each section, and can automatically combine imports from the same module. This keeps your imports clean and consistent throughout your codebase. The mypy extension provides real-time type checking as you code. Remember those type hints we talked about earlier? mypy uses them to catch type-related errors before you even run your code. It's like having a very pedantic friend who's really good at spotting potential bugs related to type mismatches. One last thing, make sure your VS Code is pointing to the right Python interpreter. Normally it picks up this location from the poetry install we did earlier, but in subsequent sessions you might want to do a poetry shell first and then start VS Code with code dot. You can see the location of the poetry Python by doing which Python after the poetry shell, and then verify it's the same Python package by searching Python interpreter on the VS Code command palette. Let's see how these extensions work together. Let's mess up our code in the application py. When you save this file with our extensions enabled, it automatically transforms into the following. Notice how the extensions have sorted imports into standard library, third-party, and local application imports, added consistent spacing around operators, and after commas, fixed indentation and line breaks, added proper spacing around type hints, ensured consistent blank lines between imports, and function definitions. This automatic formatting happens every time you save a file, ensuring your code always maintains a consistent style. mypy is also at play here. Let's change the return type of the init config to a string instead of none. Notice how the whole block is red? That file is also marked as red on the file tree. This is telling us that there's an issue with the file. You should not commit any files that are red into the repository. Let's try out VS Code's powerful debugging features. First, let's debug our running application. Open the ViewSpy file in the counter app folder and let's add a breakpoint. Click to the left of the line number where we increment our counter. A red dot will appear, indicating your breakpoint. Now press the little green button on the Run and Debug panel and make sure Python Quart is selected. Open your browser and navigate to localhost 5002. The application will pause at your breakpoint. Remember that you need your Docker database container for the application to run. In the debug console, you can inspect variables like row and count. Try typing row count in the debug console to see the current counter value. You can also use the debug toolbar to step through the code line by line or step into function calls. We can also debug our tests this way. But first stop the run command and remove the breakpoint in the views py. Open the test counter py file and set a breakpoint in our second test. Open the testing panel in VS Code and click the debug icon next to the test you want to debug. The test will run and pause at your breakpoint. You can now inspect the database connection and step through the test code. The debug console is particularly useful for async code because you can see the exact state of your application at any point in the event loop. This helps tremendously when tracking down issues with coroutines and async await patterns. While the local setup works well, I prefer using VS Code's dev container feature. Development containers provide a consistent, isolated environment that matches our production setup exactly. They eliminate the "it works on my machine" problem and make it much easier to onboard new team members. Let's create a devcontainer.json file in a new .devcontainer folder in the root path where the Docker Compose YAML is. This configuration tells VS Code to use our existing Docker Compose YAML file, start both our web and database services, set up the workspace in the /app directory, automatically install all our required extensions through the VSCode extensions section. Notice how we're installing the same extensions we installed manually in our local setup: Python, Black Formatter, isort, and mypy, and set up Poetry after the container is created. Before you run this, make sure that you delete all the images and containers that have the same name, otherwise you will get an error. When you open this project in VS Code, you'll see a prompt asking if you want to reopen it in a container. Once you do, VS Code will build the container and set up a complete development environment with all our tools and dependencies ready to go. The beauty of this approach is that everyone on your team gets the exact same development environment, complete with the correct Python version, all required dependencies, consistent linting and formatting rules, database access already configured, debug configurations ready to use. Before we run the application, remember to do your first Alembic migration. Just open a terminal on VS Code and run Poetry run Alembic upgrade head. You can now run and debug your application directly from VS Code. Run tests with the built-in Test Explorer and get immediate feedback from mypy and Black as you code.